Good morning, students. I myself, architect Amin Inam, assistant professor at School of Architecture, Galgotias University. Today we will be studying about the reinforced cement concrete frame structures, their different components, and how they are more convenient and more beneficial over the traditional construction methods. So before starting the lecture, it's very important to understand what a student should be aware of. A student should be aware of how an RCC act as a building material in the construction field, and secondly, what are the different RCC components of a frame structure. So these two things are very important to know before the starting of this lecture. So the objectives of this lecture are pretty much clear and easy to understand, that a student will understand the basic information in the RCC frame structures. He will understand how an analysis has been done in the RCC frame structure, the calculation of the various parameters during the construction in the RCC frame structures, and the importance of RCC frame structure in the construction field. So let us first start with the introduction part of the reinforced cement concrete frame structures and some important points regarding the RCC frame structures. So concrete frame structures are a very common, or perhaps the most common type of modern building internationally. This type of technology has been used throughout the world. As the name suggests, this type of building consists of a frame or skeleton of a concrete. Horizontal members of this frame are called as beams, and the vertical members are called as columns. So the frame is being constructed using these two types of frame components, the beams and the columns. Human walks on the flat plane of concrete called as slabs. Of these, the column is the most important, as is the primary load carrying element of the building. So the whole load of the building is being transferred through column to the footings and to the primed earth. If you damage a beam or slab in a building, this will affect only one floor or one part of the building, but a damage to a column could bring down the whole building. So the column is the most important part or the most important component of the RCC frame structures. Moving further to introduction part, when we say concrete in a building trade, or when we use the term concrete in this lecture, we actually mean the reinforced concrete. Its full name is reinforced cement concrete, or RCC. RCC is a concrete that consists of steel bars called as reinforced bars or rebars. This combination works very well, as concrete is a very strong in compression, easy to produce at sites, and inexpensive, and steel is a very strong in tension. So the cement which is being used without the reinforcement is very weak in tension. So when we use the steel bars or the reinforcement, the steel acts as a tension member. To make reinforced concrete, one first makes a mold called as a formwork that will contain the liquid concrete, the semi-liquid concrete, and give it the form or shape we need or required. Then one looks at the structural engineer drawing and place in the steel reinforcement bar. So the calculation of the number of reinforcement bars, the diameter of the reinforcement bar is being done by the use of engineering drawings or the working drawings, and finally those steel bars are tied together and placed using a wire. The tied steel is called as the reinforcement cage because it is shaped like one. So apart from beams, columns, slabs, there are some other components as well of the RCC frame structure. Walls and cladding are two the important parts of the RCC frame structure. So walls in a concrete frame building or the concrete frame structure concrete frame structure are strong and economical. Hence, almost any wall material can be used with them. The heavier options include the masonry wall of brick, concrete block, or stone. The lighter options include drywall partitions or that are made up of light steel or wood stud covered with sheeting boards. The former are used when strong, secure, and soundproof enclosures are required. So when there is a need of a soundproof structure or a soundproof enclosure and we need a strong structure, we use the former one or the brick masonry one, the concrete block or the stones. And secondly, there is another option of using the lighter structure when we need a flexible lightweight partition. We, we, we use a kind of a structure that is lightweight partition boards that are embedded with the RCC frame structure. When brick or concrete blocks are used, it is common to plaster the entire surface, brick and concrete together, with the cement plaster to form a hard, long-lasting finish, and then finally the paint is done. The other important component of the RCC frame structures is the cladding. The cladding of concrete frame structures are that can be used as a clad with any kind of cladding material. Common cladding material are glass, aluminum panels, stone sheets, and ceramic facades. Since these structures can be designed for heavy loading, one could even clad them with solid masonry walls or brick or stone. So this video will make you understand the whole construction of how the excavation begins and how the RCC formwork has been done and the frame is constructed. Firstly, the footing reinforcement is done as per the requirement of the load. The columns reinforcement is done as per the calculation of the number of steel bars. The concrete casting is done at the footings. Finally, the reinforcement for the ground begins. Then the concrete casting of the ground beams. So this structure is done. The primary form has been created. Then this whole structure is backlifted. The ground floor slab mesh has been created with the reinforcement. Casting of ground floor slab is done, the 100 mm thick. Then column reinforcement is done as per the calculation of the number of RCC and the steel bars. Concrete column has been done, 300 by 300 mm concrete columns. Finally, the laying of blocks. The roof beam reinforcement is done. The concrete casting of roof beams, which has the dimensions of 350 by 250. Finally, the roof reinforcement has been done. The concrete casting of the final roof slab, 150 mm thick. So this whole formwork is being done with the number of steps that are required to cast the whole structure in the RCC frame structure typology. So if we look onto the advantages of RCC frame structures over the other typology, other methods of constructing a building or the steel structures or the masonry structure, there are many advantages of RCC frame structures over the other construction techniques. So as compared to the other concrete building materials, reinforced cement concrete has a high compressive strength. The RCC frame structure building has been a better resistance to fire and weather changes than steel. The reinforced cement concrete can withstand a good tensile stress. The reinforced structure building is more long lasting than other buildings. its maintenance cost is negligible. Reinforced cement concrete can be economically molded in any required forms and shapes as per the need. In structure like dams, piers, footings, reinforced cement is more economical material because it is easy to develop a shape and size or a different form than other construction methods. It ensures that the construction is rigid that leads to the minimum depletion. So these are some advantages of RCC frame structure over other construction methods. Now we will see the different members that are together forming a frame for the RCC frame structures. These are called as framing members. So we have the roof slab, we have the shear wall, we have columns, we have footings, we have deep footings, we have basement wall, we have floor slab, and we have roof slabs. So these are the components of the framing members together forming a RCC frame structure. So the structure is actually a connected frame of members, each of which are firmly connected to each other. Like if we talk in engineering, these connections are called as moment connections, which means that the two members are firmly connected to each other. These are There are other types of connections as well, including the hinge type connections, which are used in steel structure and not in the RCC frame structures. But when we talk about the concrete frame structure, the RCC frame structures, there are 99.9% cases when we use the moment method. So this frame becomes very strong and must resist to the various loads, the different types of loads which we will discuss further in this lecture that act on the building during its whole life. Now if we talk about the different types of loads that act on the building or the RCC frame structure throughout its life, there are many types of load that act on the building. Here we are only discussing the two types of loads, the dead loads and the live loads. A dead load is the downward force on the building coming from the weight of the building itself, including the different structure elements such as the walls, the roof, facades, etc. The live load is the downward force on the building coming from the expected weight of the occupants and their activities and their possessions, including the furniture, the books, and so on. So in the picture you can see a room that has been creating a two types of loads on the downward direction to the beams, the load of the slab, the load of the walls, as well as the load of the occupant activities. So these loads will vary with the use of the space. For example, whether it is a residential space or the office space, industrial to name so. It is common for codes to require live loads for residential to be minimum of about 2000 kg per meter square, office to be 250 kg per meter square, industrial to be 1000 kg per meter square as per the spaces, which is same as 1 ton per meter square. So these live loads are sometimes also called as the imposed loads because these are the imposed on the structure. Normally these loads are specified in the building codes and structure engineer must design building to carry these two types of loads together. Now moving further, as we have discussed the advantages and of the RCC frame structure, there are some disadvantages also for the RCC frame structure. So let us now compare the advantages and disadvantages together. So advantages of the frame structure is it's the one of the best advantage of frame structure is their ease in construction. It is very easy to teach the labor the construction on the construction site. Frame structure can be constructed rapidly. Economy is the very important factor in design of a building system. Frame structure are economical designs. Now if we talk about the disadvantages of the frame structure, in frame structure, span length are usually restricted to 40 feet when normal reinforced concrete. So when we use a normal reinforced concrete means a normal typology of steel bars in a normal reinforced ratio. The span length is restricted to only 40 feet. So when there is a requirement of a large span slab, there is a method, a different typology of method, a different typology of framing a system, which require more technology and more money. So otherwise, spans greater than that, these if we use these normal reinforced cement, a lateral deflections can form. So if we discuss the types of RCC frame structures, we have many framing typology of structures, but here I am discussing the two typology of framing structures, that is the rigid frame structures and the brace frame structure. Within the rigid frame structure, there are pin-ended and fixed-ended, and within the brace frame structure, there are goblet frames and the portal frames. So in a rigid frame structure, as you can see in the figure, there is a combination of beams and columns togetherly used to form a frame. In a rigid frame structure, as the word rigid means ability to resist the deformation, rigid frame structure can be defined as the structure in which beams and columns are monolithically and act collectively to resist the moments that are generated due to the applied load, the different types of load on the structure. The rigid frame structure provide more stability. This type of frame structure resists to shear, moment and torsion more effectively than any other type of framing structure. And this type of framing structure is the most common and most economical typology of framing structure and has been used in many buildings. For example, the Burj Al Arab building in Dubai. So if we talk about the types of RCC frame structure, we have many types of RCC frame structure. One of the type is the brace structure frame. So in this frame system, a bracing is usually provided between the beams and the columns to increase their resistance against the lateral forces and sideways forces due to applied load. So bracing is done along the diagonal direction between the beams and the column, as you can see in the figure, the brace structure frame. A bracing is usually done by placing the diagonal members between the beams and columns. This frame system provides more efficient resistance against the earthquake and wind forces. It's more strong. This frame system is more effective than the rigid frame system. Now if we compare the differences between the RCC frame structure and the typical load bearing structure. In the RCC frame structure, the whole load is supported on beams and slab, while on the load bearing structure, in the load bearing structure, it is supported by the masonry wall. The load transfer path is from slab to beam, beam to column and column to footing. While in the load bearing structure, the load transfer path is from slabs to wall and walls to footing. Multi-story building can be constructed in the RCC frame structure. There is a limitation of stories in a load bearing structure. Though resistant to earthquake, if not properly designed, can be more hazardous also in the RCC frame structure. While the load bearing structure, it is much more resistant to earthquake. In the RCC frame structure, the carpet area available is more, while in a load bearing structure, the carpet area available is less. In RCC frame structure, the most common form of construction, it is the most common form of construction, and the load bearing structure is not being used now. In RCC frame structure, the excavation for the construction of RCC frame structure is less, while the load bearing structure, excavation for the construction of load bearing structure is more. So we have another method of calculating and analyzing the RCC frame structure, the strength design method. It is based on the ultimate strength of the structure member, assuming a failure condition whether due to the crushing of the concrete or due to the yield of reinforced steel bars. Although there is additional strength in the bar after the yielding has been done due to strain hardening. This additional strength in the bar is not considered in the analysis or design of the reinforced concrete members. In the strength design method, actual loads or working loads are multiplied by the load factor or obtained by the ultimate design loads through different types of codes. The load factor represents the high percentage of the factor for safety requirement in the design. So now let us see what says by the limit state method, which is also known as the load and resistance factor design. It is a further step in the previous stand design method. It indicates that the state of the member which is required to meet the service requirements, such as the losing its ability to withstand different loads or local damage. According to limit state design, reinforced concrete members have to be analyzed with regards to three limit states. The first one is the load carrying capacity, which involves safety, stability, durability. The second one is the deformation, the deflection, vibration, and the impact. And finally, the formation of cracks. So this method is being used by analyzing the typology of framework so that these three types of parameters can be analyzed throughout the life of the building. So we have different methods of analyzing the RCC frame structure. We have the working stress design method. This design concept is based on the elastic theory, assuming a straight line stress distribution along the depth of the concrete. The actual load or the working load acting on the structure are eliminated and members are proportioned on the basis of the certain allowable stress in concrete and steel. So this allowable stress R is being calculated by fractioning the crushing strength of the concrete and the yield strength of the concrete. Because of the differences in reality, over the past several decades, the strength design method has displaced the older stress design methods. So if we finally conclude this lecture, I have some points concluding the lectures. Concrete frame structure are a very common or perhaps the most common type of modern building internationally. RCC is concrete that contains steel bars called as the reinforced bars or the rebars. This combination works very well as concrete is very strong in compression, easy to produce on site, inexpensive, and steel is very strong in tension. Common example of standard mixes are M20, M30, M40, where the number refers to the strength of the concrete in Newton per mm square or Newton per square millimeter. The RCC frame allows the building to withstand tensile strength to a good extent. It is fairly resistant to extreme weather and conditions and fire. It is fluid. Reinforced concrete can be molded into different shapes and very negligible cost. RCC structure are easy and cost effective where maintenance cost is concerned. The strong structure allow flexibility in the walling options from heavy bricks to concrete blocks to light steel or the wood studs covered with sheeting boards. Anything can be used depending on the purpose and design. Some more points regarding the conclusion. As compared to other concrete building materials, reinforced cement concrete has a high compressive strength. The RCC frame structure building has a better resistance to fire and weather changes than steel. The reinforced cement concrete can withstand a good tensile stress. The reinforced structure building is more long lasting than the other buildings. If we talk about the conclusion, we have some more points regarding the RCC frame structure as the advantages and the disadvantages as well. So the disadvantages can be concluded like it needs meticulous mixing, casting, curing, all of which affect the final strength of the member. The cost of the formwork used in the cast concrete is relatively high. It has low compressive strength as compared to steel, which leads to large section of the column beam to multi-story building. Cracks develop in a concrete due to shrinkage and application of the load when the application of load is very high. If concreting is not done properly, the steel starts corroding, thereby losing strength, and ultimately the life gets reduced. Also, the repair costs are then very high and very difficult to do. So this concludes the lecture on the RCC frame structure. So these are some references that you can move further to enhance your knowledge on the RCC frame structures. Regarding this, I have 3 questions in your assignment. The first question is what are the differences between the RCC frame structure and the traditional load bearing structure? The second question is why RCC frame structure is more economical than the load bearing structure? And the third is explain the different components of the RCC frame structure of a multi-story building. So these 3 questions have to be done in your assignment, and these are the references which you can use to enhance your knowledge and getting more information on the RCC frame structure. Moving further to this lecture, in the next lecture we will continue this lecture on the analysis part, and we will discuss the different methods briefly. Thank you.